Okay, now that we've calculated the amount of heat that's gained by the juice or lost by the water, that's the gain or lost, okay, 422 kilojoules. And we need to calculate how long the pipe needs to be. We know we want all this calculation. We want to achieve that temperature. We are losing heat from the water. But our pipe has a certain dimension, certain diameter. So we must pump enough juice through the system to allow the heat exchange. So the calculation is then we need to think about how long the pipe is. And the equation that we are going to use will be this one. Energy equals to the conductivity times the area of the pipe times this delta L. Delta L here means the heat energy that's going to transfer between the water and the juice. So looking at the end of the pipe of the juice, we are looking at a temperature difference of 80 degrees Celsius minus 40 degrees Celsius. So the temperature difference at the end of the juice, but at the beginning of the water, because we pay attention to the water. So we will look at the initial temperature change of the water first. So the the change difference is 40 degrees Celsius. When we look at the end of the pipe or the heat transfer exchange system, at the end, we see a temperature difference of 50 degrees Celsius. So that's 50 degrees Celsius. The temperature gradients is different along the pipe. As we saw again, here we have a difference of 50 degrees Celsius. Here we have a difference of 40 degrees Celsius. So we will need to know an overall temperature difference along the pipe, and we will need to use this equation. Okay, something that we've derived by some genius mathematician. So it's a change of the temperature at the end. So it's 50 minus 10. Okay, and then taking the ln of 50 over, sorry, not 10, 40, because that's 40 degrees Celsius. Sorry, I make the difference. So it's delta temperature at the end, at the outlet of the water. Okay, so that's a difference of 50 degrees Celsius minus 40. That's the inlet of the water system. So it's 50 over 40. Now we will use a calculator, punch in, and we will see that there's an overall temperature difference of 44.8 degrees Celsius. We plug it into this equation. We know the energy gain. The energy gain here, we are talking about 400. So back to this equation here, UA delta T. Now, we know this from the juice here, 422 kilojoules. Our conductivity here is, here, no, this is not, this is the energy, this is the coefficient of the metal pipe. Okay, and then we know that the area is here. That's something that we need to solve. We are talking about the area. The internal is a cross-sectional look of the pipe. We need to know the area inside, the circumference here, times the length of the pipe. And that will be an equation that looks like 3.14 pi times 0.1 meter times L. That's the length of the pipe that we are looking for. How long is the pipe? And delta TL, delta temperature, is now 44.8 degrees Celsius. So again, we have one single equation here with one single variable here, and we will be able to calculate the length of the pipe that is needed to allow the transfer of energy from the hot water to the juice at 4 liters per second. Thank you.